For number 1, we have this sequence n factorial over n plus 1 factorial. It's really important you understand how these factorials are going to simplify algebraically. So let's just for an example, a5. Okay, a5, what is it? It's by definition it's 5 factorial over 5 plus 1 factorial, so that'd be 6 factorial. Okay, and even more so, I mean, what is 5 factorial? It's 5 times 4 times 3 times 2 times 1. 6 factorial is the same thing, except for it starts at 6. So you see, this is gonna drastically reduce because the 5's cancel, the 4's cancel, the 3's, the 2's, the 1's cancel. This whole thing is just going to end up being 1/6. So a5, after you simplify it, ends up being 1 over 6. You'll notice that regardless of what n is, that same type of canceling is going to always happen. So if you recognize that pattern, you'll see that an is always going to simplify to 1 over, and in this case, right, when n was 5, it was 1 over 6. And so in general, it's when whatever n is, it's going to be 1 over n plus 1. And if you, taking these factorials and simplifying it like this makes it a lot easier to take the limit as n goes to infinity. The limit as n goes to infinity of a sub n, that's the limit as n goes to infinity of 1 over n plus 1, which if n goes to infinity, this is 1 over a real big positive number, which is a really small positive decimal, and it's getting closer and closer to 0. Okay, so that limit's 0. For number 2, you've got natural log of n plus 1 minus natural log of n. What you would want to do here is recall a property of logs that says that the difference of logs is the same as the log of the quotient. So you could rewrite a sub n, that's the same as the natural log of n plus 1 over n. Okay, if when it comes to taking the limit as n goes to infinity of a sub n, so that would be the limit as n goes to infinity of the natural log of n plus 1 over n. Okay, and what we're going to do is just basically focus on the inside here. What happens as n goes to infinity to this this fraction here? We'll notice this is a rational function. It's degree 1 over degree 1. So as n goes to infinity, this thing's going to approach the ratio of the leading coefficients. And notice you got 1n over 1n, so 1 over 1 is 1. So this is going to approach, right, what's in the parentheses, it approaches 1, but we are still taking the natural log of that. Okay, so it boils down to we're taking the natural log of 1, which is 0. Okay, so that sequence also converges to 0.